Hello everyone, let's talk about odd and even functions. So the first thing, I've got an example of an odd function and an even function here. This one's even. I'm going to show you how to algebraically determine if something is odd or even, and then we'll talk about what happens in the graph. So if it says find negative x, what that means is instead of x squared, everywhere I see an x, I'm going to put a negative x, and we're going to see what happens. So f of negative x, when you plug in instead of x, you make it negative x, you're like, oh, negative x times negative x is x squared. So f of negative x equals x squared. But that's what we started with. And what's happening here is we're saying it doesn't matter if you plug in a positive or negative. If you're going to square it out, it ends up being the same. So here, f of negative x is the same as f of x. Look, here's f of negative x, and here's f of x. They both equal x squared. So how we call this is we say f of x is an even function. And what this is saying visually is that plugging in x and plugging in negative x give you the same y value. So it's the easy way to remember this is it's symmetrical about the y-axis. It's a reflection across the y-axis. All of these points you can reflect across the y-axis and get the other side of it. So even functions are symmetrical about the y-axis, and the way you algebraically prove them is by plugging in negative x, show me that it comes out to be the same as when you plug in regular x. Let's try an odd function. We're going to do the same thing. We're going to plug in negative x. That's how we test for odd and even. So negative x cubed. And let's see. Negative x times negative x times negative x will be negative x cubed. So g of negative x, when you plug in a minus sign, it ends up being minus x cubed. So we look at this guy, and we look at this guy, and we say, well, they're not the same. X cubed is not the same as negative x cubed. So it's not even, like in this one. Here they were the same. They're not the same, but this is positive and this is negative. It's the opposite. These are opposites. So if g of negative x, when you plug negative x in, you get the opposite of the function. So you put a minus sign on the outside. Then we say g of x is odd. Okay, it's an odd function. And what's happening here is there is symmetry, but it's symmetrical about the origin. It's rotational symmetry about the origin. If you plug in x and you get a y value, so like I'll make up a number. Let's say you get 1, 2. Down here, if you plug in negative 1, you will get negative 2. So this is a rotational symmetry. They're going to be opposites. And you can take this guy, and if you flip the paper over, watch, I can rotate it, but if you actually flip your paper over and you end up with the same graph, see how that's the same? Watch, I'll even duplicate it. Look, there's one, and then you flip it, you're like, oh, those are the same graph. It's rotational symmetry. So this is called an odd function. So we're going to do it algebraically and visually, and you need to be okay with both. The algebra definitely looks kind of weird because this is a proof, and we haven't done a lot of algebraic proofs. But it's not that difficult to understand that you're just looking to see, are they the same? Are these the same, or are they opposites? That's basically the game. You're going to do the same thing every time. Plug in negative x and see what happens. So here is the very mathy version of the same thing. And the main ideas are if the graph is even, then it is symmetrical about the y-axis. It's a reflection across the y-axis. So you have symmetry that way, reflectional symmetry. That is an even function. Odd functions are rotationally symmetrical, so symmetric with respect to the origin. The way we write this is f of x equals f of negative x. So when you plug in negative x, you get the same thing. Or when you plug in negative x, you get the opposite. Those are the two ways we prove or we determine if functions are odd or even. That's what we need to know. So let's try one. First, we'll do it algebraically. I'm going to plug in negative x. So it'll be 1 minus, instead of x to the fourth, I'm going to put negative x to the fourth. And I have 1 minus, and I'm like, well, this is an even exponent. When the even exponent gets taken to the fourth power, it doesn't matter. Negative times a negative times a negative times a negative is a positive. So this doesn't matter. We have 1 minus x to the fourth when we plug in negative x, and we have 1 minus x to the fourth when we plug in regular x, which means h of x equals h of negative x. So we say h of x is even. And we're going to try and be very formal here. Ooh, you want to use a therefore? How about this? That means therefore. Therefore, h of x is even. What's that mean in the graph? That means that we are symmetrical about the y-axis. So I look at points and I see if they're a reflection. I graphed it. I'm like, -1 is a reflection of +1. These are flipped. And this thing looks kind of like an upside-down parabola. It's not a parabola, but it looks kind of like a parabola. And all these points are being reflected about the y-axis. So h of x is even, which means it is symmetrical about the y-axis. Let's test g of x. So we're going to do the same thing. We're going to plug in negative x every time. 2 times negative x minus negative x squared. Everywhere I see an x, I'm just going to put a negative x in parentheses and we'll see what happens. 2 times negative x is negative 2x, and negative times a negative is a positive, so we're subtracting. This cancels out. And now we'll look at it and say, are these the same? 2x minus x squared, and that's negative 2x. So those are opposites, but these are the same. So they're not opposites because all the signs aren't flipped, and they're not the same because one of the signs is flipped. Then we're going to say, therefore, oh, you want to, let's be, like I said, very formal. Now we'll just say neither. Odd or even. I was going to say, since g of negative x does not equal negative g of x, and g of x does not equal g of x, then this is neither odd nor even, but let's not write all that. We don't need to worry about that. Look, you can see it right here. It is not a reflection about the y-axis. If you reflect points, you'd be like over here, and you'd have a whole other parabola. So it's not a reflection about the y-axis, and when I flip this thing over, it's not the same graph. When I rotate it, it's not the same function, so this is neither odd nor even. Neither odd nor even. Neither nor. Okay. Try another one. When you plug in negative x to the 5th plus negative x, and if you want to put an exponent there, it's to the 1st. So if you have a negative to an odd, it's going to survive. And again, we look at it and we're like, wait a minute, this was positive, now it's negative. This was positive, now it's negative. All these signs flipped. So when I plugged in negative x, I got the opposite of f of x. When you get the opposite, that's called an odd function. Therefore, f of x is odd. When you plug in negative x, you get the opposite of f of x. Therefore, the function is odd. And you can see that in the graph as rotational symmetry. Watch, when I flip it over, it's the same function. Okay, this is an odd function because when you rotate it 180 degrees, you end up with the same function. And you might start to notice, like, wait, odd happens when all the signs flip, and that happens when the exponents are all odd. And these are even because this is 1x to the 0. When the exponents are all even, then the function is even. Here they were both, one was odd, one was even, so it was neither. Are you starting to notice why we call these things even and odd? Let's do one more together. F of negative x. So I plug in negative x cubed minus negative x, and you get negative x cubed minus a negative is the same as adding. So when you plug in negative x, what do you get? Well, this was positive, now it's negative. This was negative, now it's positive. So we will say f of negative x equals the opposite of f of x. If they're opposites, therefore f of x is odd. Which means, again, I should be able to rotate it, and you can even look at it. This guy right here, 0.57, 0.57, 0.385, they're opposites. So this function is odd, and I can see that in rotational symmetry. See, same thing. Yay, odd function. But again, if you haven't noticed, it has to do with these guys. Those are both odd. If all the exponents are odd, the function will be odd. But I need an algebraic proof. All right, we have some practice problems. So again, when we do these things, you should hit pause. You should work out the problem. Then you should watch me do it. Because if you're practicing, watching me, you can watch me do a billion problems and it doesn't matter if you never try and do it on your own. Okay, I'm not going to be doing the test questions for you. You're going to be doing the test questions, so practice. Okay, hit pause. And we're back. Let's plug in negative x. G of negative x is negative x to the fourth minus 4 times negative x squared. So you notice, oh, those are both even. So I can ignore them. When you plug in a negative, so G of negative x, you get x to the fourth and negative 4x squared. So the way we say that is, when you plug in negative x, you get regular G of x. Therefore, G of x is even, which means it is symmetrical about the y-axis. You can see these are reflections of each other. It's a nice, pretty W for Wyatt. Yeah? Reflections about the y-axis mean the function is even, and the way you test it, you always plug in negative x every single time. Look, plug in negative x, plug in negative x, plug in negative x, plug in negative x every time. One more. F of negative x equals negative x squared plus negative x. Okay, negative x times negative x is positive x squared, and that's just going to be minus x. So, let's see. Are these the same? No. Are they opposites? No. This one's positive, and this one is an opposite. So, one of them is opposite, but they're not all opposites. So, that means this is neither odd nor even. Neither nor. And you can see that in the graph. It is not symmetrical about the y-axis, and I think it's obvious that if I flip this thing over, it will be a different graph. So it is neither even nor odd. Okay, that's our start for even and odd. So go ahead and get your checkpoint done, and also hit that like and subscribe button.